All right, today we are going to start a chapter on statistics. And this first section is about probability of something happening. So for example, let's look at this little scenario here. For lunch, here's the menu. You've got 4 different types of sandwiches that you can choose from. And you have 3 different sides and 4 different desserts. They want to know, if you had to pick one sandwich, one side, and one dessert, how many different combinations can you come up with? Okay, so we're going to look at the fundamental counting principle, and what you do is you look at how many choices you have for sandwiches. How many choices are there?
4,
How many choices for sides?
3,
And how many desserts?
4.
If you multiply these numbers together, there are 48 different ways you can pick from these items. So let's look at, here's another example. This is a more simpler example. Here's your fundamental counting principle. If you have 3 pants and 2 shirts, how many different types of outfits can you come up with? Well, if there's 3 pants and 2 shirts, 3 times 2 is 6, or 6 possible outfits. Okay, so that's what we are doing today. Next example. Maryland used to have this license plate right here. It used to consist of 4 digits, that's it. So how many possible license plates could the state of Maryland in 1912 come up with? Well, if there's 4 different numbers, each number, there's, excuse me, 10 different numbers you can pick from. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Or, I'm not 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers. Okay? So, how to figure out how many possible license plates in the year 1912? You would do 10 times 10 times 10 times 10. And you get 10,000. Well, in the year 2004, they changed things up. They did this situation. They did 3 letters, followed by 3 numbers. Well, there's 26 letters of the alphabet, so 26 times 26 times 26 times 10 digits times 10 digits times 10 digits. If you multiply that out, you get 17,576,000 types of license plates. So if they are asking you a question like, how many more license plates in 2004 were possible than in 1912, the difference of these, which is that number, 17,566,000, that is the number of more license plates that they could have create in 2004 to go with the increase in population. Okay? So let's see if you can do this next one. Let's say in 1966 there was a license plate where they had 2 letters followed by 4 digits. So we have 2 letters. And then 4 digits. So how many possible combinations can we come up with? How many letters in the alphabet are there?
26.
And the reason why we can say 26 times 26 is because you can use the same letter twice. Then there's 10 digits, 4 times. If you multiply these numbers together, does anyone have the answer yet?
60,000.
Yep. You got it. It's a big number. 6,760,000. Okay? Let's look at problem 2. Problem 2. So you have 12 different folders. and you wanna know how many different ways can you arrange those folders, one after another. So, how many different ways? Well, you've got 12 folders, but once you use one, you're not going to use it again. So this is a little different. Instead of doing 10 times 10 times 10 times 10, you're gonna do 12. In the first folder, you have 12 options. In the second spot, you have 11, because you've already used one. So this is called factorial. So when you see this, 12 with an exclamation, that does not mean 12, wow. It's not like, yay 12, go 12. It means 12 factorial means 12 times 11 times 10 times 9. So what you're doing is you're taking the biggest number here, and you're gonna multiply it by 7, 6, 5, 4, 3, I'm running out of room, 2, and 1. All right, I'm gonna show you on your calculator how to do this. Turn your calculator on. Go to menu. Go to probability and factorial. That is where you're gonna get your exclamation mark. So if you wanna know 12 factorial, 12 factorial, you hit 12, hit menu, hit probability, and then factorial, you're gonna see the exclamation and then hit enter. And there's your answer, which matches what we have here. 479,001,600 different ways that you can arrange 12 folders.
How do you do it? What do you put? Menu and what?
You do menu, let's do the next one. You do menu, you first put the number in, 12, then hit menu, probability, factorial, and then hit enter. Did you get it?
Yeah.
Okay, next one. How many ways can you arrange, if you had 8 shirts, and you're gonna arrange them in your closet, once you hang a shirt, it's hung, you're not gonna use it again. So this would be an example of 8 factorial. How many different ways can you hang your 8 shirts? So this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's 8 factorial. Instead of doing that on a calculator, you're gonna go like this. You're gonna type in the number 8, then hit menu, probability, factorial, and hit enter. Believe it or not, there's 40,320 different ways. To hang 8 shirts on a hanger in a closet, believe it or not, isn't it crazy? Okay, now, if order matters, for example, look at example 3. You've got 10 students in a race. 10 people are running. And first, second, and third places are gonna win a medal. How many ways can those 10 runners finish first, second, and third with no ties allowed? So this is gonna be a permutation problem where order matters. Permutation looks like this. You're gonna have N, P, R. Okay, so you're gonna look at N is the number of people that are in this race. So it's gonna be, you're gonna write 10, P, and then R, we have 3 places that matter. Take it 3 at a time. So 10 runners taken 3 at a time, that's basically what you're doing. So this formula looks like this, it's N factorial over N minus R factorial. So you're gonna do 10 factorial over the difference of these, 10 minus 3, which is, what's 10 minus 3? 7. So it's 10 factorial over 7 factorial. Well, let's write this out. What is 10 factorial? It's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What's 7 factorial? 7, 6, 5, 4, 3, 2, 1. What cancels?
7, 6.
All these. So basically what you're doing is multiplying not 10 times 9 times 8. That's the number of ways you can take 3 at a time out of 10 runners. So the answer is 720. 10 runners to arrange taking 3 at a time. So there's 720 different ways that 10 runners can finish in first, second, and third. Now, how can you do this on the calculator? This is a permutation. Take your calculator. I want you to hit menu, go to probability, and the second is permutations. Hit enter. You should see NPR. What I need you to put in the parentheses is what's the total number of runners, 10. Then put a comma, and you're taking 3 at a time. So it's 10 comma 3, and there's your answer. So I want you to try the next one. Got it? How many ways can 15 runners finish first, second, and third? So out of 15 runners, we're going to take 3 at a time. So you have, this is a permutation problem, 15p 3 at a time. So it looks like this, 15 factorial over the difference of these factorial. So 15 factorial over 12 factorial. Now, I want you to see this. If you write it out, you've got 15 times 14 times 13 times, what's going to happen with the next set of numbers from 12 on?
Cancel.
And so forth. I'm not going to write them all out. On the bottom, you have 12 times 11 times 10. You're going to cancel all these out. So basically, it's the difference of these two factorial. Or not factorial. Not factorial. It's 15, the difference of these multiplied by each other. So 15 times 14 times 13. If you multiply those together, you will get 2,730. Now, how do you do it on a calculator? See if you remember what I just told you. What do you hit? Menu.
Probability.
Probability.
Permutation.
Permutations.
15.
15, taken 3 at a time.
Counting.
You get the same number?
Yep.
Cool. Awesome. Okay, now, check this out. What if, suppose in problem 3, the first 3 runners advance to a championship race. In this case, order does not matter who finishes first, second, or third. The first 3 people, we're going to have them advance to a championship race. This is now going to be a combination problem. Combination looks like this. So when you see 5C3, you have 5 total, taken 3 at a time, and order does not matter. So this one you're going to do n factorial, so 5 factorial, 5 factorial. So if you see 5C3, 5 factorial over, this is your R value, you've taken 3 at a time, so 3 factorial, and then times the difference. So in other words, this part looks just like a permutation. But in the bottom, you're going to multiply the bottom by the R factorial again, so 5 minus 3 factorial. Now let's do this by hand. First, 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and this is going to be 2 factorial. Well, these cancel, 3, 2, 1 cancels. 2 goes into 4 2 times, so what's left? 5 times 2 is, the answer's 10. Now, how can you get this answer doing it a different way? Well, go to menu, go to probability. I'm going to use combinations now. NCR. 5, comma, taken 3 at a time, and hit enter. And there's your answer 10. So here's an example, another example. The number of combinations of 13 items taken 4 at a time. So order does not matter in this case. So it'd be 13 factorial over 4 factorial times the difference of 13 minus 4, so 9 factorial. So here it is long ways. You get 715 for an answer. Let's practice these 3 together. Make sure everyone can do these. 8C3. 8C3, it would be 8 factorial over 3 factorial times 5 factorial. So by hand, 8, 7, 6, 5, 4, 3, 2, 1. And then 5, 4, 3, 2, 1, that's that one. And 3, 2, 1. What cancels? Those. And what's 3 times 2? Everyone, 3 times 2
6.
is 6, and that 6 cancels with that. So what's left? An 8 times 7, which is 56. Try it on your calculator. Make sure you can do both. I want you to be able to do both ways. Menu, probability. We're going to do 8 items. We're doing a combination of 8 items taken 3 at a time. I can't see, did I put the comma in here? No. Comma, 3. And there's our 56. How about the next one? 9 items taken 2 at a time. So it'd be 9 factorial over 2 factorial times 7 factorial. What'd you get out of this answer? Anybody?
36.
36 is correct. Now, there's another way you could do this problem I want to show you. Thank you. How else could you have done this problem without using combinations? Well, I'm going to hit my fraction key. You guys remember how to get the fraction key?
Yeah.
Okay. On top, I'm going to type in 9 factorial. So 9, then go to menu. This will take you a while. And number 1 is factorial. Arrow down, you're going to do 2 factorial, 2, menu, probability, factorial, and then times 7, menu. Whoop. And then hit enter. And you get 36. The same answer as if you were to hit menu, probability, combinations, 9 taken 2 at a time. Let's check this out. There you go. Same answer. How about the last one? What'd you get? Menu, probability. We're going to take 15 combinations, 5 at a time. And order doesn't matter. You get 3,003. And that would be 15 factorial over 5 factorial times 10 factorial. So, when you're doing a permutation or a combination, you have to know if order matters. Here's 2 examples of when order matters and doesn't. So for A, you've got a chemistry teacher and they're dividing the class into 8 groups. And each group is going to submit a drawing. And the teacher's going to select 4 of the drawings to display. Does order matter? No. Doesn't matter how this teacher picks the 4 drawings and displays them. So this would be How many groups are there? There's 8. There's 8 groups, we're gonna take 4 at a time. So this is a combination problem. It's 8 factorial over 4 taken at a time, and then times the difference of those two. You end up with 70. So you can do this on your calculator like we just did, or you can do it by hand. Now, what if this situation occurred? You sell 25 lottery tickets, and we're gonna give first, second, and third place winning. How many different ways can you draw the 3 winning tickets? This one order matters, because once you win, you're not gonna win it. You can't win first and second place. So for this one, this is a permutation problem. This is gonna be, there's 25 tickets, 25 over the difference, 25 taken 3 at a time in order matters, so it's 25 minus 3. So if you do this by hand, it's 25 factorial over 22 factorial, or really just 25 times 24 times 3, which is 13,800. If you do this on a calculator, you're gonna hit the permutation button, and it's 25 comma 3. How would you do this last problem? It says, in problem 5A, which is the chemistry teacher, that teacher is going to, out of the 8 groups, they're gonna display 4 drawings, but they're gonna put them left to right, so there's a specific order that you're putting them in. This is now an example of a permutation problem. You're taking 8 drawings, and you're gonna organize them in a particular order. So this would be a permutation problem. So this would be 8 factorial over 4 factorial, which is 8, 7, 6, 5, 4, 3, 2, 1, over 4, 3, 2, 1. These cancel, so all you're doing is multiplying 8 times 7 times 6 times 5. You can type this in your calculator this way also. Either way, you'll get the right answer, 1,680. Different ways to arrange the 4 drawings from left to right. Questions? Okay, the rest is homework. Emma, can you turn that off?